Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. My advice on how to pass actuarial exams is at smarturl.it/pass. This video channel is at smarturl.it/pass actuarial exams. Here you have information about online seminars and study manuals for exams P, FM, IFM, and LTAM that I offer. I direct the actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. If you would like to offer a tax-deductible donation to support our students, please go to smarturl.it/help-ISU-actuary. Here's a problem for today for exam P on the probability. The length of time in years that a person will remember an actuarial statistic is modeled by an exponential distribution with mean 1 over y. In a certain population, y has a gamma distribution with alpha equal to 2 and beta equal to 1/2. Calculate the probability that a person drawn at random from this population will remember an actuarial statistic less than half a year. Let t be the random time for the length of which a person remembers an actuarial statistic. We are told that f sub t of t, given that y is equal to y, is y times e to the minus yt, that's the density, as well as s sub t of t for y equal to y is e to the minus yt, that's the survival function, for an exponential distribution with hazard rate y, so the mean is 1 over y. Note the following. The probability that t is greater than or equal to 1/2 is the integral from 0.5 to infinity of f sub t of t. That's the integral from 0 to 0.5 to plus infinity of the integral from 0 to plus infinity of f sub ty, the joint density of ty dy. And we switch the order of integration. This becomes the integral from 0 to plus infinity of the integral from 0.5 to infinity of f sub t y of ty, first with respect to t, then with respect to y. Then it's the integral from 0 to plus infinity of the integral from 0.5 to plus infinity of f sub t of t, given that y is equal to y dt, times f sub y of y dy. And then that's the integral from 0 to plus infinity of the survival function at 0.5, given that y is equal to y, times survival function of t, times f sub y of y dy. But of course that survival function is just e to the minus 0.5y. So this is the integral from 0 to plus infinity of e to the minus 0.5y times f sub y of y dy. Now recall that the moment-generating function of a gamma random variable y with parameters alpha and beta is m sub y of u equal to beta over beta minus u to the power alpha. And actually, you can just use it for this specific case where alpha is equal to 2, and notice that this kind of gamma distribution is just the sum of two exponentials. And this is a square in practice. Here, it's a square of the MGF of exponential random variable. So anyway, the probability that t is greater than or equal to 1/2 is the integral from 0 to plus infinity of e to the minus 0.5y times f sub y of y dy. This is the moment-generating function of y evaluated at negative 0.5. And the beta parameter in this case is 0.5, so it's 0.5 over 0.5 minus negative 0.5 squared. That's 1/4. And therefore, the probability that t is less than 1/2 is 1 minus that, and that's 3/4, and that's answer D. Please remember this is copyrighted material. The problem itself belongs to the Society of Actuaries. The solution is mine. Good luck in your studies and good luck on the test.